Elon Musk has once again lifted the curtain on Tesla's boldest roadmap yet, unveiling a strategy that carries both daring ambition and precise execution. After closing out a record-setting third quarter that left competitors stunned and investors leaning forward, Tesla is not slowing its momentum. Instead, the company is charging into the fourth quarter with a vision that stretches beyond simply building cars. It is about reshaping entire industries, from consumer transportation to energy storage, from artificial intelligence to autonomous mobility. Each piece of the roadmap slots together like an intricate puzzle, where the entry-level electric vehicle, the reimagined Model Y, and the emergence of robotaxis converge with advanced chip design, battery megafactories, and freight solutions that challenge diesel dominance. Musk is not speaking in tentative language. This is Tesla with a deliberate direction and a sharpened sense of scale, promising that the company is not just chasing headlines, but setting the foundation for what comes next. At the center of this unfolding chapter is the highly anticipated Model 2, Tesla's answer to the demand for a truly affordable electric vehicle that retains the essence of the brand while stripping away unnecessary frills. Designed as a compact 5-seater, the Model 2 takes the proven architecture of the Model Y and distills it into something leaner, simpler, and significantly more cost. Unlike luxury EVs that chase prestige, the Model 2 is crafted with mainstream adoption in mind, using a smart combination of modular components, simplified manufacturing methods, and advanced casting techniques that replace dozens of welded sections. With massive single-piece structures, these gigacastings, one for the front and one for the rear of the chassis, not only eliminate production complexity, but also bring down weight, material costs, and assembly time. Tesla has spent years mastering this process, and now the company is deploying it at scale to bring down costs in a way that few traditional automakers can replicate. One of the most significant innovations inside the Model 2 lies not in its design, language, but in its electrical backbone. The low-voltage system, which in most vehicles has traditionally been a 12-volt setup, is being upgraded to a 48-volt network with distributed zonal controllers. This shift might sound minor to a casual observer, but in reality, it represents a leap in automotive engineering efficiency. A 48-volt system can deliver the same electrical power as a 12-volt system while requiring only a quarter of the current. That means dramatically thinner cables, lighter connectors, and huge weight reductions across the wiring harness. For example, supplying 950 watts at 12 volts would require a thick 4-gauge wire weighing around 2 kilograms. With a 48-volt system, Tesla can achieve the same power transfer with a far lighter 10-gauge wire weighing only about a quarter of a kilogram. This is an 85% reduction in wiring mass, translating not just to cost savings, but also to real-world efficiency gains. Reduced resistive losses mean less wasted energy, which in practice adds nearly 10 kilometers of range, while simultaneously cutting up to 150 pounds of material from the car. In the relentless pursuit of efficiency, these savings are not incremental, they are transformative, especially when multiplied across millions of vehicles. Tesla further enhances this architecture by using Ethernet-based zonal controllers, which simplify the car's nervous system. Instead of a tangle of individual connections and dozens of chips handling isolated functions, the network is consolidated, streamlined, and easier to diagnose. This design not only reduces weight but also improves reliability and lowers production costs. Efficiency in manufacturing and in operation is a theme that repeats throughout the Model 2's engineering. The drivetrain follows the same philosophy. The base variant employs a compact permanent magnet motor mounted at the rear, a design chosen for its balance of efficiency, manufacturability, and performance. This motor shares components with Tesla's broader lineup, keeping the supply chain tight and uniform. To complement the motor, Tesla uses high-frequency inverters, which reduce the need for large passive components and simplify the thermal system. A single integrated heat pump loop now manages the heating and cooling needs of the cabin, the battery, and the power electronics. This level of integration eliminates extra hoses, brackets, and separate subsystems, while also improving cold weather performance and enabling faster charging. Inside the Model 2, Tesla doubles down on the theme of simplicity and durability rather than luxury excess. The cabin is governed by a single central touchscreen that replaces the need for redundant controls. Steering is handled through a stock-free interface, while modular components like seat frames, door panels, and dashboard assemblies are designed for rapid installation with minimal fasteners. Surfaces are durable, easy to clean, and intended to withstand years of heavy use, making the vehicle ideal not just for individual owners but for high-utilization scenarios such as rideshare fleets and corporate carpools. Gone are non-essential features like rear-seat entertainment screens or ambient lighting. Instead, Tesla has focused on delivering safety, efficiency, and the core comforts that matter most. Compared with the Model Y performance or long-range trims, the Model 2 does not chase luxury. Compared with the Model 3, It is even more rugged and modular, intended to endure demanding environments. It is not a stripped-down Tesla, but a right-sized one, preserving what owners value most: affordable running costs, convenient charging, and advanced software capabilities. While the Model 2 captures attention with affordability, Tesla is simultaneously preparing to broaden its family-oriented lineup in Europe and China, where multi-occupant SUVs have surged in popularity. Tesla has been spotted testing a camouflaged prototype of a 6-seat Model Y. This variant is expected to prioritize comfort and accessibility, featuring a two-seating arrangement with independent mid-row seats and a rear row for 2 passengers. This configuration is far more user-friendly than the conventional 7-seat arrangement, which often crams 3 passengers into the middle row and creates a difficult squeeze into the third row. Instead, the 6-seat Model Y offers a center aisle for easy passage, a design especially helpful for families with children or elderly passengers. Wider per-seat space, roughly half a meter per passenger in a 1.5-meter wide cabin, means a more premium feel, with elbow room expanded by nearly 25% compared to the 7-seat design. The 6-seat variant is not just a comfort upgrade. It is a strategic product designed for markets where large families and ride-sharing demand make such layouts essential. With European families preferring premium electric SUVs and Chinese consumers fueling a surge in demand for multi-seat SUVs, Tesla's move here is tactical. The model strengthens its position in family mobility, builds customer loyalty, and positions Tesla against rivals like the Toyota Highlander and Honda Pilot, all while staying true to Tesla's design ethos of combining practicality with cutting-edge performance. But Tesla's story is not just about vehicles, it is also about the technological foundation that powers them. A landmark development in this regard is the $16.5 billion contract Tesla has signed with Samsung to produce the AI6 chip. This 9-year agreement ensures Tesla has a steady supply of its custom-built AI processors from 2025 to 2034, manufactured at Samsung's advanced facility in Texas. The AI6 chip is Tesla's third-generation AI accelerator and will be a cornerstone of the company's entire ecosystem. Built on a 3-nanometer process, with plans to shrink further to 2 nanometers, the chip contains 8 tensor cores and delivers 5 exaflops of performance in a compact package, measuring just 35 millimeters on each side. That staggering level of computational power is not just about making cars drive themselves, it unifies Tesla's hardware for its autonomous vehicles, its humanoid robot, Optimus, and its data centers. The advantages of the AI6 chip are profound. It is 10 times faster in inference tasks compared to the older AI for chip, while consuming significantly less energy. That efficiency translates into quicker decision-making in vehicles, lower operating costs in data centers, and a competitive edge that Tesla can defend because it owns the entire pipeline from chip design to software deployment. Owning this design means less reliance on external vendors, a critical advantage at a time when chip shortages have disrupted global industries. Analysts estimate that AI6 delivers 3 times the throughput per watt compared to earlier generations, making it not just powerful but also highly efficient. Tesla's decision to discontinue its previous Dojo supercomputer project underscores how central this chip has become. Instead of splitting tasks across different hardware for training and inference, Tesla is unifying them under AI6. It will handle real-time decisions in vehicles, process humanoid robot actions, and train future iterations of AI, all with a single, scalable platform. This convergence is Tesla's way of focusing resources, reducing redundancy, and accelerating progress toward a fully automated ecosystem.